Okay, we're going to start talking about limits now. It's a new concept. It's pretty big in calculus. We've understood it when we did horizontal asymptotes and advanced functions, but now we're going to put some math to it and eventually properties of limits. So I'm going to make a statement here, and then I'm going to help you understand limits in a table and in a graph. And then 1.5 will do more limits in equations, which is generally where we want to go. But without the visualization, we don't really understand things. So let's take a look at this statement. It looks like gibberish maybe. So this means the limit of a function, okay, which you don't know what it is yet. Let's say it equals a number L. All these L's are the same. It could equal 5. It could equal who cares. This notation here means as x approaches a. As x approaches a. So the limit of a function is L as x approaches a if and only if the limit of the function equals L as x approaches a. So take a look at this notation from the right. So as you move from infinity to the function, or to a, what's the limit? And the limit of the function has to be the same if you're approaching from the left. So if you're going from two directions, the limit of the function needs to be the same for it to be a limit that exists. Okay, so again, a limit as x approaches a only exists if you're approaching that number, that a value, from left and right, and it equals the same thing. So let's take a look at what that means, if that doesn't make any sense. Let's say we want to find the limit of, as x approaches 1, of this rational function x squared minus 1 over x minus 1. So let's say we have a table of values. We can graph this, but let's take a look at the table of values. All I'm going to do is I'm going to plug in a bunch of points, and I'm going to approach 1. And as I approach 1, see 0, 0.5, 0.9, 0.99, I'm going to get closer and closer to 1. Now we know that I can't have a value of 1, right? Because it's undefined. Not allowed if I plug in 1. So we can't find the limit by just plugging it in, always. So I'm going to go ahead, I'm going to plug in 0, and I'm going to get the value of 1. I'm going to plug in, my calculator, 0.5, get this. Then I'm going to get 1.9, 1.99. So I can see that from the left side, I'm approaching 2. So I think my answer is 2, but that's not enough, because it's not enough for it to be approaching from one side. Sorry, that would be this side. I got to go from the other side. So I'm going to plug in 2, and I'm going to get 3. Let's plug in this, 2.5. Plug in the next one, 2.1, 2.01. Take a look. From the right side, as I approach 1, my limit is approaching 2. And from the other side. So I can actually make a little conclusion here that mimics this statement. I can say that, therefore, the limit as x approaches 1 for x squared minus 1 over x minus 1 equals 2. Okay, that's my answer, but now I'm going to give my explanation in a different color, because that's what I do. Because the limit of x squared minus 1 over x minus 1, 1 from the left side equals 2, and the limit as x approaches 1 from the opposite side is also 2. So because these are both 2, this is correct. It's the only way. It's got to be from both sides. So let's take a look at that visually. So I have a piecewise function here. I didn't write down the equations. I just graphed it just so it makes it a little simple. So I want to find out the limit of this function. This is f at x over here, as x approaches 1. Same idea. So I have to approach 1 right here, and obviously there's something happening here, right? If I was approaching 3, the limit would just be my answer there. It would be easy. Just plug in 3. That's too light. Okay, there's always going to be something that's complicated for you to figure out. So the limit, let's write this down right away, as x approaches 1 from the right, and the limit of f at x, I don't even know what f at x is, just in case you're wondering, what's f at x? We don't care. Okay, so this, sorry, I'm running out of space here. From the left side, the function, we trace, dun, 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 we reach here. My limit from the left side is 0. It's going to 0. However, if I trace from positive infinity, think of it like you track onto the function and you keep going until you can't go, until I reach 1. The limit here is 2. So So if I come from the left, the limit's 0. If I come from the right, the limit is 2. Therefore, big therefore statement, the limit of the function as x approaches 1, it doesn't matter if it's from the left or the right, 1 from this statement equals does not exist. Does not exist. I can't find the limit as x approaches 1. Okay, so limits graphically are pretty simple. By table, they're pretty simple. As we get into 1.5, doing it algebraically, you just have to do some math things to make it allowed, or to simplify it, really. That's it for 1.4, limits.